Welcome to revision week 2. This time we are looking at the FDE cycle and the CPU performance, which is all paper 1. Okay, can you make sure you've got sheet 2 in front of you that you were given in lesson ready to complete? Sheet 2. Okay, quick recap just before we go into new stuff. Remember, we've been looking at the CPU. The CPU is made up of different parts. You've got the control unit, which controls the flow of data. We've got the arithmetic logic unit that carries out all the mathematical and logical operations. We've got the cache, which stores quick access memory, stores regularly used data. And we've got the registers that store tiny bits of data. And also the buses that transport the data around the CPU. And remember, the purpose of the CPU, if you get asked in the exam, is to process data and instructions. And it does that by carrying out the fetch, decode, execute cycle of instructions. Fetch, decode, execute cycle. And we also looked last time as well at the registers, the super quick memory, the 4 registers where the program counter, which holds the address of the next instruction, the accumulator, that stores the results of any calculations from the ALU. The memory address register holds the memory address about to be used by the CPU. And the memory data register holds the actual data or instruction that's being used at the moment as it's copied from memory into the CPU. Those are the 4 registers that you need to know. Why are we going back over that again? Because you need to understand that so you can understand the next part. Okay, here we go. So we know that the parts of the CPU, we know that the instructions are stored in memory over here, in memory, okay? The CPU carries out the fetch, decode, execute cycle to process the instructions. It fetches an instruction from main memory, from RAM. It copies it into the CPU, where it decodes it, the control unit decodes it, and then it executes the instruction, it carries it out. That's a very simple version, okay? That's not enough detail for the exam, but that's the simple version of how it works. Fetch, decode, execute, and then it goes and gets the next instruction. One time around is one cycle, or one FDE cycle. Okay, let's have a little bit more detail now. Don't worry about taking notes for a second. Just take a moment to listen and make sure we understand what's going on, and then we'll make sure we write notes. So what happens in the FDE cycle? You start off with the program counter. The program counter stores the address of the next instruction. Remember, we learnt about that. The program counter, here it is. Okay? The program counter points to the address of the next instruction, the first instruction, in main memory, in your RAM. The program counter copies its address down to the MAR, the memory address register. Copy from the program counter to the MAR. The instruction is then fetched from that address in memory. Wherever that instruction is, it goes to RAM, goes and gets it, and brings it back and copies it into the MDR, the memory data register. Whatever was in that address, 01, is copied back into the MDR. And now that you can see we've got an instruction there. We don't know what it is yet, but we've copied it in. And then finally, the program counter is incremented. It's added 1, so it's ready for the next instruction. If we didn't do that, we get stuck on doing the same instruction again and again and again. All of that is the fetch stage. After fetch, we then decode. Well, we've got the instruction here in RAM, in the MDR, but we don't know what it is. So the instruction in the MDR is decoded by the control unit. The control unit decodes it. And look, we now know that means add 6. So now we know what add 6 is. The control unit, may then load a new value into the MAR, MDR, ready for the next stage. In this case, it's loaded the number 6 in there, ready to use. And finally, now we've decoded it, we are going to execute it. We're going to carry out the instruction. The instruction is then performed or carried out. Could be load, could be write, could be add, whatever that instruction is. In this case, in this example, it's add 6. We're going to add the value 6 to whatever is in the accumulator. So in this case, the value 6 is added to whatever's in the accumulator already. 6 plus 8 gives us 14. And that value is then stored in the accumulator, ready to do something else, maybe on the next instruction. The cycle is now finished. You would then go on, the cycle would then start again with the next instruction, 0, 2. It would go to memory, go get it, bring it in, and decode, etc. Okay? That is one time through the FDE cycle. Now you've watched, you can always rewind and watch that again if you want to understand. Okay, let's make sure we understand the basics. What do you need to know for the exam? Fetch. The memory address is copied from the program counter to the MAR. That's the first thing that happens. Boom, boom. That instruction is then fetched from main memory. If you can remember that, that's easy. The instruction is fetched from main memory. And the instruction is copied into the MDR in the CPU. From memory, copied into the MDR. The program counter is then incremented to point to the next instruction. So there are 4 things you could say there. I recommend the ones in yellow, the easiest to remember. Decode. The instruction is decoded by the control unit, and a new value may be loaded into the MDR or MAR ready for the next stage. And finally, execute. The decoded instruction is then carried out. And then the cycle is repeated with the next instruction. Fetch, decode, execute. Fetch, decode, execute. Fetch, decode, execute, etc. So, now we've gone over it, I'd like you to write down at least 2 things that happen at each stage. In the exam, you are very likely to be asked about one of these stages, or maybe all of it. Okay? 2 things that happen that fetch, decode, and execute. Onto your sheet, and then check your answer in a second on the next slide. Okay, if you've paused the video and written down, ready to check your answers. Okay, fetch, instruction is fetched from main memory, instruction is copied into the MDR. And remember, for more detail, the instruction in the program counter is copied to the MAR, and the program counter is incremented. You could also have. Decode, the instruction is decoded by the control unit, and a new value may be loaded into the MDR MAR. And execute, decoded instruction is carried out, and then the cycle is repeated again. Okay, one other thing to know, the FDE cycle, fetch, decode, execute, one time around this cycle, one time around is called 1 Hertz. One cycle is 1 Hertz. 1,000 times around per second is called 1 kilohertz, 1 kHz. 1,000,000 times per second would be 1 megahertz, and 1,000,000,000 times per second is 1 gigahertz. Bearing in mind, most modern CPUs are something like 2.4 gigahertz, that means 2.4 billion instructions or cycles per second. Okay? So on your sheet, make those down now, please. 1 hertz is 1 FDE cycle. 1 kilohertz is 1,000 FDE cycles. 1 megahertz is 1,000,000 cycles per second. And 1 gigahertz is 1,000,000,000 cycles per second. Okay, last part of this video. Are all CPUs the same speed? No, they are not. There are several things that affect the speed of the CPU. There is the clock speed, the number of cores, and the size of the cache. These are the 3 things you need to know that affect the speed of how fast it can do the FDE cycle and other things. How fast can it process instructions? The clock speed, that is simply the number of instructions it can process, it can carry out per second. How many FDE cycles can it carry out? Like we just said, modern CPUs, 3.5 gigahertz means it can do 3.5 billion instructions or FDE cycles per second. Faster the clock speed, the more instructions it can process per second. Also that affects it is the number of cores it has. Now a core is a processing unit within the CPU. Each processing unit or core can carry out the FDE cycle on its own, one FDE cycle. So if you have two cores, it means it can do two FDE cycles at the same time. If it has four cores, it can do four FDE cycles at the same time. The more cores, the more instructions it can carry out simultaneously at the same time. There we go. Look, single core, one core, dual core, two instructions at the same time, quad core, four instructions, FDE cycles at the same time. The more cores you have, the more instructions it can do simultaneously at the same time. And very lastly, the last thing is cache memory. Think about cache memory as somewhere you can store data, okay? Normally, you'd have to go all the way to RAM, to your fridge, to get instructions, okay? During the FDE cycle. Go to the fridge, go to RAM to get things, like in your kitchen, getting food and things. Think of cache as like memory inside the CPU, a bit like having a mini fridge in your bedroom. Instead of having to go all the way downstairs to the kitchen, you can just go to the mini fridge in your bedroom to get stuff that you use regularly. That's my analogy for this, okay? It's quicker to go to cache than having to go all the way down to RAM. So very simply, cache is very fast memory inside the CPU that stores data, regularly used data, so it can access it quicker than having to go to RAM. The more cache you have, the more space there is to store regularly used data, so it doesn't have to go to main memory as much. Okay, 3 questions on here for the 3 factors. Write down your answers and then unpause the video to check on the next bit. There we go. Checking your answers. Number of instructions a processor can carry per second, the clock speed. The higher the clock speed, the more instructions it can process per second. Cores, a processing unit inside the CPU. Each core can carry out an FDE cycle. And the more cores you have, the more instructions it can carry out at the same time. And cache size. Fast access memory inside the CPU stores regularly used data instructions. More cache, more regularly used data, less going to main memory. Now you're finished with the sheet. Final part of the homework, go to Learn Dean. You're completing revision quiz 2. Under revision, revision quiz 2. Check out each answer, improve, correct it if you need to. You should be getting 100% by the end of the quiz. Good luck, and I will see you next week in lesson.